All right. Greetings, YouTube. Beautiful Mind here. All right. So, support for College Algebra. We are pretty much in the home stretch. This is Wednesday for week 7. So, what I decided to do, I'm going to go ahead and do the lecture for Wednesday today, and go ahead and do the lecture for the next class, which is Wednesday, which is Friday of week 7. All right. So then for week 8, it's really just completing your assignments, right? So I think I went on and loaded all the remaining assignments for the quarter. The final exam is loaded. The remaining assignments are up. You get unlimited attempts at all assignments. If you want to go back to any old assignments, you can redo them. You can boost the score. The highest you can get on a late assignment, the highest you can get on a late assignment is 90%, right? So like, you know, if you wanted to go back and get an A, you can. But yeah. So when we submit assignments promptly, then you can get potentially 100%. But then after the due date, it's a 10% late penalty. So you can still get an A if you want, but then you have to get everything fully right. Okay. But yeah, I am here. If you have questions, you know, I hadn't really been going back and forth a lot, but I've been here. You know, and it's just, you know, everybody's doing the best that they can. So the main thing is that we've completed our participation and honesty quiz via Moodle, and we are submitting all the assignments that we see on Pearson. Most of the grade is going to come from Pearson. I mean, pretty much your grade comes from Pearson. I take it and then just feed it into our setup, our rubric or whatever. Okay. So I hope everyone is doing well. Like I said, I'm gonna go ahead and do the lecture for Wednesday and Friday of this week, and then that'll be the end of the new material. Okay. So we will start off. We'll continue chapter 6 of rational expressions and equations with section 6.6, solving rational equations. Some objectives here are 1, to solve rational equations with integer denominators, and 2, to solve rational equations where a variable appears in the denominator. A rational equation is one that contains one or more rational expressions. For example, we have 1/2 x plus 3/5 x equals 8. Okay. I'm going to I guess I'll just read through this. So to solve rational equations, determine the LCD of all fractions in the equation, multiply both sides of the equation by the LCD. This will result in every term of the equation being multiplied by the LCD. So again, keep in mind that terms are things that we add and subtract. And factors are things that we multiply. Remove the parentheses and combine like terms on each side of the equation. Solve the equation using the properties discussed in earlier chapters, and then check our solution in the original equation. So for example, excuse me, we have factors are things that we multiply. We have this. It says solve for t. Okay. So let's start. Nope. So for example, does it undo work? Nope. We have all right. We have this. It says solve for t. Okay. So let's start. What if I go like this? Does that make a difference? All right. Well, I can worry about it. Okay. So we have this t by 4 minus t by 5. And we have this equal to 1, right? So if we look at the fractions, the LCD of the fractions, so the LCD in this case, let's put it here. So we have this least common denominator is going to be 20, all right? So we're going to multiply the entire left-hand side by 20 and the entire right-hand side by 20. So then ultimately what happens is that we have this t by 4 is going to be multiplied by 20. Let's see. Minus this t by 5 is going to be multiplied by 20. And then 1 times 20 is 20. All right. So this is going to be multiplied by 20. This is going to be multiplied by 20. Okay. So then with that first term, 20 divided by 4 is 5. 5 times t is going to be 5t. 20 divided by 5 is 4, so that's going to be minus 4t equals 20. So then t equals 20, because 5t minus 4t is 1t. 20 divided by 4 is 5 times t. So then, we could check. With stuff like this, we get an answer. The beautiful thing about this is that we are able to check. Let's do this. That's totally not the word check. I have no idea what I just wrote. Chinned? I don't even know what that is. So then, we could check. It is kind of early. So let's do a quick check. All right. So then if we did 20 divided by 4 minus 20 divided by 5, the question is, does it equal 1? 20 divided by 4 is 5. 20 divided by 5 is 4. Again, does that equal 1? 1 indeed equals 1. It checks out. Okay. All right. So then we have a typed up version of what we just did. And then there's a check. Okay. So solving rational equations, any value of the variable that makes a denominator 0 must be excluded. Therefore, when we solve rational equations where a variable appears in any denominator, we must check the values obtained in the original equation to avoid any excluded values. If a value makes any denominator 0 of the original equation, if a value makes any denominator of the original equation 0, that value is not a solution of the equation and must be excluded. Such values are called extraneous roots or extraneous solutions. Okay. So for instance here, note that x can't be 0, because if x were 0, we would have a 0 in the denominator. So from the beginning, we notice that x cannot be 0, right? So then when we go to solve the equation, we still want to identify our LCD. So if we look at the denominators, we have 2 and x. So the LCD in this case is going to be 2x. So we're going to multiply every term by 2x. Okay. So that means we're going to have this 4 times our 2x. So we're going to say the entire left-hand side by 2x and the entire right-hand side by 2x. So multiplying the left and right by the LCD, it clears the fractions for us, right? So we're going to have that 4 times the LCD minus the 5 by x times the LCD equals the 3 by 2 times the LCD. And again, the LCD in this case, so we're going to have this times 2x, this times 2x, and this times 2x. Okay. So if we account for this, 2x times 4 becomes 8x. So notice, so we have a 2x on top and an x on bottom. This x cancels this one, and 5 times 2 becomes 10. So that's going to be minus 10 equals, on the right hand side, the 2 on top cancels the 2 on bottom. So we have a 2x on top and an x on bottom. This x cancels this. So then we're left with 3x there. All right. So then we want to isolate our variable. So I'm going to subtract 3x. If we subtract 3x on both sides, on the left, we're going to have 5x. If I add 10 to both sides, then we're going to get 10 on the right. Divide both sides by 5. X equals 2. Okay. So then we want to do a quick check to confirm. Let's see, we have 4 minus 5 divided by 2. The question is, does that equal 3 by 2? All right. To add and subtract fractions, we need a common denominator. So that 4 becomes 8 over 2 minus 5 over 2. The question is, does that equal 3 over 2? 8 minus 5 is indeed 3. So 3 over 2 indeed does equal 3 over 2. Checks out. It makes sense in the context of the original. Okay. LCD is 2x. Blah, 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 blah. And then we do a quick check, and it checks out. It makes sense in the context. Okay. Use cross multiplication to solve. So in this case, it's kind of like we have a fraction equal to another fraction. So in this case, we can cross multiply. Okay. So let's see. We have this x plus 1 under 9 equals x minus 3 under 5. Okay. So then if we cross multiply like this, again, we can cross multiply because it's like we have one fraction equal to another, right? So then what we're going to get, and let's just do like this. We're going to get this 9 times x minus 3 equals 5 times x plus 1. Okay. So as you kind of watch this video, you know, don't hesitate to pause the video and attempt these yourself. Like, the more you can do on your own with less input, the better. It's okay to get input, and then that just means you have to kind of practice a little bit more on your own. But you know, the more that you can do yourself, the better off you'll be. Okay. So then we're going to distribute here. On the left, we're going to get 9x minus 27 equals 5x plus 5. We use the inverse operation. So if we want to isolate the variable, we would subtract 5 on both sides. 9x, let me see, 9x minus 5x is going to be 4x. If we add 27 to both sides, what is that? 32. 27 plus 5 is going to be 32. So if we have 4 times x, use the inverse operation to isolate our x. We're gonna divide both sides by 4. X equals 8. Okay. Oh, and then the other thing that we forgot to do in the beginning, notice that x cannot be equal to -1 or 3, right? Because if x is -1 or if x is 3, they make the denominator 0. We got an answer of x equals 8. We can actually confirm this by checking. So let's check. We want to see, is it the case that 8 plus 1 under 9, is that equal to 8 minus 3 under 5, right? So then 9 over 9, the question is that equal to 5 over 5? 1 indeed equals 1, and it checks out. Okay. So then 9 over 9, the question is that equal to 5 over 5? Okay. So let's give this one a go. So first things first, notice x cannot be equal to what number? X cannot be equal to 6, all right? So if we get 6, we know that's not the answer. Let's call it an extraneous solution. I like to call it the right-wrong answer, because algebraically, our moves typically are sound, but then again, that's an extraneous solution, so we have to always check and make sure that it works in the original. Okay. So in this case, again, we have it's like one fraction equal to another, so we can actually cross multiply here. We can do this, right? So if we do that, on the left, we're gonna have x squared minus 2x times x minus 6, and that's going to be equal to 24 times x minus 6. Okay. On the left, we're going to have x squared minus 2x. So we can expand. If we FOIL on the left, let me see, we're going to get x cubed. Let's just erase it. That's going to become x cubed. First outer is going to be minus 6x squared. Inner minus 2x squared. And last is going to be what? Plus 12x. And then that's going to be equal to 24x. 6 times 2 is 120, so 144. 144, right? We're going to move everything to one side, so we're going to set it to 0. Might need a little bit more space, but let's set it to 0. So if we combine like terms and move everything to the left, let me see, I might be able to get it to fit. So then we have x cubed. Let's see, negative 6 minus 2 is negative 8x squared. 12 minus 24 is minus 12x. And then plus 144 equals 0. Okay. So then we want to see, can we factor this thing on the left? There is no greatest common factor, so nothing is common to all terms. When I see this, I was like, I feel like I could do, let's try a factor by grouping, right? So if we group the first two together, what do they have in common? They both have what, x squared? Okay. If we factor out x squared, then what's left is going to be x minus 8. All right. I don't think we get the x minus 8 in the second part, so that doesn't work. They both have what, x squared? Let's see. If we factor out x first squared, outer, inner. X minus 8. 6x squared minus 2x squared plus 12x. 6 times 2 is 120. 44. Subtract negative 12. 144. What if we switch those around? Oh, is this a cubic function? Subtract negative 12. It's not one of those. What if we switch those around? Oh, is this a cubic function? X minus 8, okay. And there we're going to get what, x minus 12, so that doesn't work. Even if I switch those around, we're going to get what, x squared. What if I group those two? Does that help? X minus 8, okay. And there we're going to get what, x minus 12, so that doesn't work. Even if I switch those around, we're going to get what, x squared. What if I group those two? Does that help? So that didn't work. Can I try the first 3? Let me see. If we try factoring for the first 3, that's a negative 8. That's 12x. Okay. To those 3, we could factor out the x. We'll have x squared. First 3. Let me see. If we try factoring. Let me see. We'll have x squared. So two numbers that multiply to 12 and add to 8. Let's see, the factors are 1 and 12, 2 and 6. Okay, I'm gonna try it. I'm gonna see if it works. Let's see. So a lot of this is discovery. You do have to like have a set of tricks kind of like at your disposal, and then you just have to try it until you get something that works, right? So let's try the following. I'm still gonna keep trying factor by grouping. I'm still going to keep trying to do the factor by grouping, but I'm going to group it this way and see if that makes a difference. So I'm going to consider the first 3 because I know sometimes that works too. So if we look at the first 3, we can factor out an x, and then that's going to leave us with, I don't know if this is going to work either, because we get x squared minus 8x minus 12 plus the 144 equal to 0. That part by itself, what if we rearrange it? Because this should factor into x minus 6 times x plus 2, but then that part by itself. But then we can't really get to that 144. I was kind of hoping it would be a perfect square. Let me see. I'm gonna try one other thing, and then I might get the answer. And I'm gonna kind of go back and make sure that I've done my numbers properly. X minus 6. So let's, what I'm gonna do is the following. So I'm gonna rearrange it and see if that does anything. We can try x cubed. Let me see something. Instead of distributing, if we had subtracted there, we could factor that out. I might go back. Ooh, that seems like a bit stretch. Okay, first let me try this and see if this works. If this doesn't work, I got another idea that we could try. So I'm gonna rearrange it and see if this helps at all. 8x squared plus 144, okay, equals 0. So now after rearranging, let's try factor by grouping, right? So then if we do this, the first two we can factor out of x, and we're left with x squared minus 12. 12. We can factor out of 8. Can we factor out of 8? But that's not going to give us the number that we need. Because the 8 would have to be a 12 in order for us to get an x squared minus 12. Okay. So, let me see. I have one other idea to try. I'm going to scrap this. Let me see. I think I can get rid of all of this. I want to go back to the first line. So when I was working, I noticed something with the first line that we can also try. Okay. So let me see. I have one other idea. All right, let's do this. So, I want to go back to the first line. So when I was working, I noticed x squared minus 2x, x minus 6. Now, instead of expanding those out, let's just go ahead and set it to 0 from the rip, right? Okay. So now from the rip, if we do that, we'll have x squared minus 2x times x minus 6. Then it's going to be minus 24 times x minus 6 equals 0. So now if we do this, notice that they both have the x minus 6. So we can actually factor out that x minus 6. If we factor out the x minus 6, what we're going to be left with is x squared minus 2x minus 24 equals 0. This is much better, right? I mean, but that's how it goes sometimes. It definitely goes that way sometimes. So then now let's try factoring that thing on the right. So we have this x minus 6, and then can we factor this into something of this form? We have x and x, plus and minus. Two numbers that multiply to give us 24 and add to give us 2. So let's go down the list. Let's go through the list of 24, right? So, and let's use this color. So let's look at the factors of negative 24. Notice that negative 24 is what? 2 times 12. But then 12 is 2 times 6. But then 6 is 2 times 3. So we're going to stop at the line that adds up to negative 2. Okay. So we have negative 1 and 24, but that adds up to 23, so that's no good. We can do 2 and 12, but that adds up to 10, so that's no good. We can do 3 and what, 8, that adds up to 5, and we want 2, so that's no good. We can do 4. Notice on the left, I'm just going 1, 2, 3, 4, and then we have 6, right? And this adds up to positive 2, so we need to do 4 and negative 6. These are the two numbers that we're looking for. Man, that was an adventure. So we're going to do plus 4 and minus 6. Okay. Yeah. Okay. Well, we were able to do it. We got lucky. All right. So we got it in completely factored form. So then we use the zero factor property. When things multiply to give us 0, we essentially just set each one equal to 0, right? So if we say x minus 6 equals 0 and solve, then x equals 6. That's what's going to make that 0. If we have x plus 4 equal to 0, then x is going to be equal to -4, right? I think in the beginning we said that x cannot be 6. So we actually can't use that one, that solution. So the only one that we were going to consider, we're going to consider x equals -4. Let's try to do a quick check. I'm about out of space. I'll start to check. Let me move this. So if we say x plus 4 equals 0, then x equals -4. Let's try to do a quick check. I'm about out of space. I'll start to check. Get rid of this. Let me move this. So if we say okay. So then let's do a quick check. Okay. So we want to see if x equals 4. We want to see if that works. So then the question is, if we do 4 squared minus 2 times 4 over 4 minus 6, is that equal to, oh, that's a -4 there. This is a -4 squared, and that's a -4 there. Is this equal to -4 minus 6 under 24? Okay. That's going to be what? 16. 4 times 2 plus 8 over -8. Does that equal 24 divided by -10, right? 24, it doesn't look like it, right? Did we make a mistake? 4 times 4 is 16. 2 times 4 is a positive 8. Oh, there it is. I see my mistake. 24, it doesn't look like it, right? Did we make a mistake? Nope, not that color. 4 times 4 is 16. So that's what, a -10 there. Then 24 divided by -10, 24 divided by -10. Does that equal? It does. Like, that's not a question anymore. It doesn't equal 24 divided by -10. Okay, so it checks out. Again, we can't use the 6 because if we try 6 in the original, it gives us zeros in the denominator. Let's see my time. Going for about 40 minutes. Okay, I got stuck on that one a little bit, but we got it. We were able to make our way through it. Okay. Got a result. We checked it. We can't use the 6 because if we try 6 in the original, it gives us zeros in the denominator. Oh, did I make that mistake? I cross multiplied. Yeah, they multiply both sides by the LCD, which is fine. Like, yeah, I was like, that should have happened. Theirs is going to be way easier. Yeah, that's fine. They multiplied the left and right by the LCD, which is fine. I cross multiplied, so that's why mine didn't cancel, and that's okay. I was like, anyway, I was just on autopilot, but we essentially still get the same result. That should have happened. Theirs is going to be way easier. All right, remember the x can't be 6. All right, because it's going to give us a 0 in the denominator. So we saw 2 different ways of doing the same thing. All right. Since 6 is an extraneous solution, the only solution is -4. Okay. So, okay. All right. So give me a moment to go ahead and load 6.7, and we're just going to go ahead and do Friday's lecture right now. I'm available, guys. Ladies and gentlemen, if you have questions, we have. Let me just go ahead and load this other assignment, and we'll do like a wrap up to kind of discuss what I'm looking for. All right, I'll be right back. I'm available, guys. Ladies and gentlemen, if you have questions, we have. Let me just go ahead and load this other assignment, and we'll do like a wrap up to kind of discuss what I'm looking for. All right, I'll be right back. I'm available, guys. Ladies and gentlemen, if you have questions, we have. Let me just go ahead and load this other assignment. All right. And we are back. All right. Let's see. Okay. So we're going to move into the last of the new material for the quarter. So this is it. We're in the home stretch. Okay. I'm watching the clock. I see the time. You know, it is what it is. But we need to go ahead and finish this. I think the audio's fine. So let me turn this down. Let's see. Okay, so we're going to continue chapter 6 of rational expressions and equations with section 6.7, rational equations, applications, and problem solving. Okay. So some objectives here. We want to set up and solve applications containing rational expressions, set up and solve motion problems, and set up and solve work problems. Okay. So let's look at this example 1. It says the city of Tampa's downtown renovation plan includes a rectangular piece of land for a community park. The park has an area of 60 square miles. The width of the park is 5 miles less than 3/5 of the length. Determine the length and width of the park. Let's read that again. We have that the city of Tampa's downtown renovation plan includes a rectangular piece of land, so the basic shape is a rectangle. It says the park has an area of 60 square miles, okay, so we can use that. It says the width of the park is 5 miles less than 3/5 of the length, okay. Determine the length and the width. Okay, so we have this image. Okay, so I want to say for this one, the hardest part is already done for us, where it says the park has an area of 60 square miles. Okay, so we can use that. It says the width of the park is 5 miles less than 3/5 of the length. They've already kind of written the expressions for us, right? I think we said what the area was 60 square miles. So we also have that the area is going to be 60 miles squared, right? So then we can get an expression. We can take this 3/5 x minus 5. So the formula for area of a rectangle is length times width, right? Then we're going to say times x, and we want that to equal 60. Okay. So I'm gonna set it to 0, right? Oh no. So the formula for area of a rectangle is length times width. So we can distribute this x, and I'm going to set it to 0. I'm going to do a couple of steps in one. Let's see. So we're going to get 3/5 x squared minus 5x minus 60 equals 0. I'm going to go ahead and clear out my fractions by multiplying the left and right by the LCD. LCD in this case is going to be 5. So I'm going to say the entire left by 5 and the entire right by 5. Okay, we're essentially going to distribute here. Now if we do this, 3/5 of 5 is just going to be 3, so that's going to become a 3x squared minus 25x minus what, 30 or 300 equals 0. Okay, so then we want to see, can we factor? Okay, notice that the leading coefficient is not a 1, right? Okay, let's do this. So we're looking for two numbers that multiply to give us 900. So 3 times 300 is going to be a negative 900, right? But then notice that 900 is what? 9 times 100. So that means we have 2 times 2 times 3 times 3 times 5 times 5. Because it's 10 times 9, right? And 10 is 2 times 5, right? So these are our factors that we're considering. And so we want to go through all the factors until we get to the line that adds up to the 25, right? So if we go through all the factors, we're going to have negative 1 times 900, but that doesn't add up to what we want. We can do negative 2. If we do 2, what is that? 450? But that doesn't add up to what we want. We can do 3. If we use the 3, we have what? 4 times 3 is 12 times 25. If you have 12 quarters, what is that, 300? Oh, duh. Yeah, 300. Okay, but that doesn't add up to what we want. We can do 4. We have a 4. What's left is 9 times 25. So 225. If we had 9 quarters, right, that'd be $2.25. But that's not what we're looking for. Can we do 5? Yeah, we can do 5. If we do 5, 6 times 6 is what, 36 times 5? So 150 plus 30 is 180. But that doesn't add up to what we want. Can we do 6? We can do 6. If we do 6, we have 6 times 25. So what is that, 150? We're almost there. But notice that doesn't add 25 either. Can we do 7? There's no 7 in that list up top, so we can't do 7. We can't do 8 because there's not an 8, but we can do 9. If we do 9, we have what, 100? But that adds up to 91, so that's not what we're looking for. Can we do 10? We can do 10. If we do 10, we have 10 times 9 is 90. But that adds up to 80, so that's not what we're looking for. We can't do 11. We can do 12. Now, if we do 12, we did the 4 times 3. What's left is 25 times 3, which is 75. But that's not what we're looking for. We can't do 13. We can't do 14. We can do 15. So then what's left, 6 times 2 is 12, times 5 is what, 60? We're almost there, but that's not it either. Can we do 16? We can't do 16, 17, 18 is what, 9 times 2? We can do 18. So if we've used the 9 and the 2, we have 25 times 2, which is 50 left over. We're almost there, but that's not it either. 18, 19, can we do 20? We can do 20. Now if we do 20, the 4 and the 5, we have 9 times 5, which is 45. And notice that 45 minus 20 is indeed 25, okay? But we want negative 25, so that means the two numbers we're looking for are 20 and negative 45, right? Okay, I'm going to do a demo on the box method for factoring. Okay, so in the box method, we have something like this, right? In the upper left-hand corner, I'm going to put the 3x squared. That's our leading term. In the bottom right-hand corner, I'm going to do my negative 300. That's my constant term. And then those two, we're going to rewrite, what is that, negative 25? So this negative 25x, that negative 25x, we're going to rewrite using those two numbers that we just found. We're going to rewrite negative 25x as a positive 20x plus, what was the other one? Negative 45x. So we rewrote that 25 as a positive 20 and negative 45, okay? So with this, if we look at the two numbers on top, we got, what's the greatest common factor between 3x squared and 20x? They both have what, x? So we rewrote that 25. They both have x in common. If we look at the two on the bottom, greatest common factor, they both is at least 5. If we look at the two numbers on top, we got, I don't know that that's a GCF though. Between 45 and 300. If we look at the two on the bottom, is it 9? They both is at least 5. Let me see. I know it's 5, so it's at least a 6 that we can get out of both. 6 times. Let me see. 6 times. Does 6 go into 45? 6 times 9. 6 times 7. 36, 42. So 6 is not going to out. So it's at least a 6 that we can get out of both. Is that not divisible by 3? 5 and 4 is 9. Oh, 15. Okay, I see what I was doing wrong. Yeah, 15. We can at least do 15, right? So then that becomes a 3. 15 there is a 20. Yeah, so 15. Okay. So we can factor out a negative 15 from both of those. All right, that should be the greatest common factor. Because the 3 is left there, and 20 is left there. Okay. If we look at the two on the left, what do they have in common? They both have 3x is the greatest common factor. And then the two on the right, we can factor out positive 20. All right, I think this looks good, okay? So then, to factor the thing on the left, it should factor into this 3x plus 20 times this x minus 15, and that should equal 0. Let's just do a quick check to make sure that we factored that properly. If we expand, we get 3x squared. What is that? Minus 45 plus 20 is a minus 25. And then minus 300. Okay, this looks good. So now at this point, now that we factor, we use the zero factor property. I'm gonna go back to my blue. So now what should be the case is that either 3x plus 20 equals 0 or x minus 15 equals 0, right? So if we subtract and divide, so now at this point, now that we factor, x equals negative 20 by 3 or x equals 15. So based on the context, because we're doing distance, we're not going to take the negative distance, so we're only going to take this one. Okay, I thought I was going to need more space. So our claim is that let x be 15. So then if x is 15, to find the dimensions, I think I will use orange just to get it to pop. So let's see, 15 divided by 5 is 3 times 3 is 9, minus 5 is 4. So the width is 4, and then the length is 15. I think these are miles. Units here are miles. So let's see, 15 divided by 5 is 3 times 3 is 9, okay. Minus 5 is 4. So the width is 4. And then all right, let's see, how do we do? That's a typo. The 3/5, it's supposed to be 3/5 x minus 5 is the width. So the area of a rectangle is length times width. So then okay. So the area of a rectangle is length times width. So I think they're proceeding the way that we did. All right. So both sides about 5. It's looking similar to what we did. So I think they're proceeding the way that we did. Okay. All right. 5. It's looking similar to what we did. So therefore the length is 15 miles and the width is 4 miles. Okay. All right, let's try another one. So it says while rollerblading, Jason warms up at a slower speed for 1 mile and then increases his speed and travels for an additional 12 miles. Jason's faster speed is 3 times his warm-up speed. If the total time Jason spends rollerblading is 1 hour, determine his warm-up speed and his fast speed. Okay. So it says while rollerblading, I guess I'll just go back and forth. So this one is a distance. Rate times time equals distance, so distance equals d equals rt. So I usually like to solve these with a chart. We're gonna look at his fast versus his slow. Okay, so let's make a chart. Oh no, I don't want that. So this one is a distance. Okay, I'm just gonna go here. Let me see if I can see it here. Okay, I think I can use this. We're gonna look at his fast versus his slow. Let's see if I can make those bigger. Okay, let's do this. So we want to make a chart. We're going to consider his fast speed versus his slow speed, right? We're going to use the formula rate times time equals distance. Okay, so we're making a chart. Fast speed versus his slow speed. Okay. We're going to use the formula rate. So it says while rollerblading, Jason warms up at a slower speed for 1 mile. Okay. So I'm going to let R be his slower speed. So if R is his slower speed, right? So it says while rollerblading, Jason warms up at a slower speed. It says then he increases his speed and travels an additional 12 miles. It says Jason's faster speed is 3 times his warm-up speed. So the faster speed is going to be 3R. Okay. It says the total time that Jason spends rollerblading is 1 hour. We know the distance. Let me see. It says Jason's faster speed is 3 times his warm. Jason warms up at a slower speed for 1 mile. So we know the distance at the slower speed is 1 mile. The units here are miles. It says the total time that Jason spends rollerblading is 1. Time is in hours. We know the distance. And the rate is in miles per hour. Miles per hour. Okay. At the slower speed, he does that one for 1 mile. Okay. The units here are miles. Time is in hours. Increases his speed and travels for an additional 12 miles. At the faster speed, he travels 12 miles. All right. So if we want to try to get an expression for time in this case. So if rate times time equals distance, I think this should be okay. Hopefully I'm not. So that means the time is going to be what? The distance divided by the rate. So if we want to try to get an expression. So his time, let me see. So if rate times time equals distance. Okay. It should be okay. So an expression for the time for his fast speed, if we say 12 divided by 3r, that's going to give us what? 4 over r. So his time, let me see. And then for the slow speed, that's going to be 1 over r, right? Okay. Then it also says that the total time he spends rollerblading is 1 hour. So we know that the time for the fast speed plus the time for the slow speed is going to equal 1 hour. So then what should be the case? Okay, I think I have everything that I need. So then what should be the case is that 4 over r plus 1 over r should equal 1 hour. So those 2 times added together should equal 1, right? So now with this, we have a rational equation. To clear it out, we're going to multiply each term by the LCD. In this case, each term by r. Okay. If we do this, the following happens. These r's cancel, these cancel. On the left, we get 5. On the right, we get r. So the claim is that his rate is what? 5 miles per hour at the slower speed. So he goes slow. His slower speed should be 5 miles per hour. And then his faster speed should be 15 miles per hour. Okay. So he goes slow. All right, let's see, how do we do? Now, let me see. 5 miles per hour. And his faster speed should be 15 miles per hour. Okay. Let's see, how do we do? Now, Oh. But that's not what the question asks, is it? The question, let's go back and look at the question. Make sure we answer the question. Determine his warm-up speed and his fast speed. Okay. Yeah. Okay, I'm gonna go with this. Let's see, how do we do? The question. Distance equals rate times time, right? Yeah. So I think we got both of these. Okay, I'm gonna go with this. Let's see, how do we do? So the warm-up speed should be 5 miles per hour. Rate times time, right? Yeah. So I think we got both. All right. So it was an adventure. Let me see how many slides we have remaining. Oh, we got a good amount. We're gonna keep going. Let's try another one. So this one says that Bob can plow a field by himself in 20 hours. Mary can plow the same field by herself in 30 hours. How long will it take them if they work together? Okay. No, I don't want to see that. Okay. So this one is similar to distance equals rate times time. I think I'm going to go back to black for this one. We have Bob versus Mary, right? So we have Bob and we have Mary. So it's, again, to solve a work done problem, it's similar to a distance problem where it's like rate times time equals distance. But in this context, we're going to say rate times time, and it's going to equal the amount of work done. Now the logic here is a little bit different than the way we did the last one. The setup is similar, but the thought process is a little bit different, right? Let me see if I can, okay. So the example says that Bob can apply a field by himself in 20 hours. Okay, so if Bob works alone, his time, and again here the time is going to be in hours. Okay. So the example says that Bob can apply a field by himself in 20 hours. So if Bob, let me see. So he can do the job by himself in 20 hours, right? Mary can do the same job by herself in 30 hours. Okay. If they work together. Okay. So if Bob, let me see. Let me think about it. So he can do the job by himself in 20 hours, right? Mary can do the same job by herself in 30 hours. If they work together. Okay. Different amount of time. Let me think about it. In order to do one job, it's going to take him some unknown amount of time. Do they have any? Let me see if we have anything. Okay. To do one job is going to take him this amount of time. In order for her to do the same job. Do they have any? Let me see if we have anything. Let me see if we got any other information. If he works by himself, it'll take him 20 hours. Okay. Okay, I'm gonna change my setup a little bit. Blah, blah, blah. If they work together, okay. So for this time, I did the time as if they were working by themselves. I'm gonna let that time be if they work together, right? So that 20 and 30, that time slot, I'm gonna let that be if they were working together, right? So let's go back to Bob. So in order for Bob to do this one job, if he's working alone, it's going to take him 20 hours. In order for Mary to do the same job working by herself, it'll take her 30 hours. So Bob's rate is one job done every 20 hours. Mary's rate is one job done every 30 hours, right? So then the question asks if they work together. So if they're working together, they're going to spend the same amount of time doing that task, right? So then if they work together, this chart is based on if they're working together. Then the amount of work done by Bob is going to be T over 20. The amount of work done by Mary is going to be T over 30. Okay. So then if they work together, this chart is based on if they're working together. So the question should be how long is it going to take them if they work together? How long will it take them if they work together? Okay. Okay. So then the final part that we need, so if the T over 20 is the amount of work done by Bob and the T over 30 is the amount of work done by Mary, then what we want to say, if we take the amount of work done by Bob plus the amount of work done by Mary, again, in order to do that same one job. Okay. I need a pen. I need a pointer. Or I need to be able to undo. If we take the amount of work done by Bob, but yeah. Plus okay. The amount of work done. If I turn this off, can I point? No. In order to do that same one job. No, that's okay. All right, let's just keep going. Okay. So now, if we multiply by the LCD, I think the LCD in this case is going to be 60. So if we say the left, basically we're going to say this times 60, this times 60, and this times 60. We'll clear out our fractions. So what is that? 30t plus 20t in order to equal 60. We get 50t equals 60. 6 over 5. So what is that? 30t, 6/5 of an hour. So an hour, we get 50t equals 60. 60, what is that, 12? 1 hour and 12 minutes. So if they work together, it should take them 1 hour and 12 minutes. If they work together. 1 hour and 12 minutes. Is that right? Does that make sense? 20 hours? So if they're working by themselves, I don't know how I feel about this. Let me think about this again. That's a 30t. That's a 20T. That's 60.
So if they're working by themselves,
50.
I don't know how I feel about it.
6/5 of an hour.
That's a 30T.
So if they work by themselves, it'll take them 20 and 30 hours, but if they work together, it'll take them like an hour. Is that right? Some don't seem right about that.
50.
Let me think about it one more time. So if he's working by himself, it takes him 20 hours. So he does one job every 20 hours.
So
if they work together, they're going to spend the same amount of time.
30 hours, but if they work together, it'll take them like an hour. Is that right? Some don't seem right.
Okay, let's see how do we do. I got an hour and 12 minutes. I can't see anything where I may have fudged the number.
Working by himself, it takes him 20 hours. So he does one job
or anything.
Oh,
okay, I found it. I was like, that didn't make sense. I was like, they're not going to gain that much time. I found the error. Okay, I found the error. I usually would offer extra credit for something like this. This is totally not right, because I was like, that don't make sense. I was like, that's too much of a boost. All right, so my error actually is back in the beginning. I didn't distribute the 60 properly, right? So notice, I was like, wait a minute. If it takes them like 20 or 30 hours by themselves, they're going to get a boost. You would expect it to take less time, but not that fast, that much faster, right? So the error is back here. 6 divided by 2 is 3. That's supposed to be a 3T, and I think I had like 30. 6 divided by 3, and that's supposed to be a 2T, and then that's 60. That's better. So then we get 5T equals 60. T equals, what is that, a 1, 10, 12 hours. That's more reasonable. Yeah, that's more reasonable. So if they work together, the time should be 12 hours. Okay, I feel better about that. Yeah, no, I'm glad I didn't have to look at the answer. Like, I feel kind of defeated when I'm working it and I have to look at the answer. Then, sometimes that happens, right? And it's okay. 12 hours makes way more sense. That's a lot more reasonable.
So if they work together, the time should be 12 hours.
All right, let's see how do we do.
Yeah, no, I'm glad I didn't have to look at the answer. Like,
so we got all that.
When I'm working it and I have to look at the answer, then, sometimes that happens, right? And it's okay. 12 hours makes way more sense.
12 hours. So if Bob and Mary work together, they can plot a field in 12 hours. We'll leave the check for you. Okay. All right, I think we got maybe one or two more. All right, I see the time. I know we're going a little long, but I just decided to go ahead and do today's lecture and Friday's lecture right now. Okay. So this example says that Carol Ann and Ashanti own a coffee shop and are roasting coffee beans that will be used to make coffee in the shop. Carol Ann by herself can roast the beans in 5 hours, and Ashanti by herself can roast the beans in 8 hours. After Carol Ann roasts the beans for 3 hours, she needs to leave the shop and visit her mother. How long will it take Ashanti to finish roasting the beans working by herself? Okay.
Carol Ann by herself can roast the beans in 5 hours, and Ashanti by herself can.
So this is still a work done problem.
After Carol Ann roasts the beans for 3 hours, she needs to leave.
Let me think about it. So we still want to make a chart.
Finish roasting the beans working by herself.
So let's get a sense for both of them. Let's do like this.
So this is still a work done problem.
Carol Ann and Ashanti.
Think about it. So we still want to make a chart.
Carol Ann and Ashanti. Okay. And we're still going to use rate times time equals the amount of work done. Okay. We're still making a chart.
We're still going to use rate times time.
Okay.
Equals the amount.
So let's go back. It says Carolyn and Ashanti own a coffee shop and are roasting the coffee beans that will be used. Carol Ann can by herself roast the beans in 5 hours. All right. Okay. So in order for Carol Ann to do one job, she can do that job in 5 hours.
Let's go back.
Okay.
It says Carolyn and
Ashanti by herself can roast a bean in 8 hours. In order for Ashanti to do the same one job, she can do it in 8 hours. Okay.
So in order for Carol Ann to do one job,
it says that Carol Ann roasts the beans for 3 hours. So she goes for 3 hours.
In 8 hours. In order for Ashanti to do the same one job, she can do it in 8 hours.
She needs to leave the shop and visit her mother. How long will it take Ashanti to finish roasting the beans by herself?
It says that Carol Ann roasts the beans for 3 hours. So she goes for
That's
3
her
hours.
rate. So then we want to see her time, right?
She needs to leave the shop and visit her mother. How long will it take Ashanti to finish roasting the beans by herself?
So it looks like Carol Ann is going to do 3/5 of the total work, because 1/5 times 3 is going to be 3/5. And the amount of work done by Ashanti is going to be T over 8, right? So we have the amount of work done by each person. So then the setup is similar, right? We're going to say the amount of work done by Carol Ann plus the amount of work done by Ashanti in order to do that same one job. Okay.
So we have the amount of work done by each person.
So then we can still multiply the left and right by the LCD. In this case, every term by what? 40. So this times 40, this times 40, and this times 40. Okay. If we do this, 40 divided by 5 is what? 8 times 3. That's going to be, it's going to become a 24.
So this times 40.
40 divided by 8 is what? 5 times t. That's going to become 5t equals 40.
If we do this, 40 divided by 5 is what? 8 times
Subtract the 24. 5t equals 16. 34.
40 divided by
16.
5 times t. That's going to become 5.
So then the time is going to be 16 divided by 5. What is that? 3 hours.
5t equals 16.
Not 20, 12. 3 hours and 12 minutes. Is that right? I think that sounds. Take her a little bit longer.
So then
3 hours and 12 minutes.
16 divided by 5.
So if we get,
3 hours.
that's going to be 3 hours and a fifth of an hour. 60 divided by 5 is 12, right? 3 hours and 12 minutes. I think that's okay. That's reasonable. If it takes Carol Ann 3 hours, but she seems like she can work a little bit faster. That's a reasonable answer, right?
3 hours.
Okay, let's see how do we do. Let's see how do we do. Ashanti's time.
3 hours.
So then 3/5. So that means Carol Ann is going to do 3/5 of the work. Ashanti's going to do x over 8. So then Carol Ann's part plus Ashanti's part in order to do that same one job. Yeah, so we had the right setup at least. 40, and I think we should have crunched the numbers fine.
So then 3/5. So that means Carol Ann is going to do 3/5 of the work. Ashanti's going to do
So 3.2 hours. That's right. That's what we got.
Carol Ann's part plus Ashanti's
Okay.
part in order to do that same one job.
All right. And with that, we actually reach. Let's go like this. That's fine. So that actually concluded the last of the new material for support for college algebra. Okay, so I went on and did Wednesday's lecture and Friday's lecture just now. Let's see. So that'll wrap up week 7. So then just for the remaining time that we had left for the quarter,
Support for college algebra.
like I said, all assignments are posted on Pearson. All assignments, the final deadline for everything is going to be Saturday, May 16th, because that following Monday is our last class. The final exam, I think I did go ahead and make it available all the way until the very last minute of class. So if we meet like Monday, Wednesday, Friday at from 10 to 11:50, that means the other assignments are going to be that Saturday before that Monday. But then that Monday, the final exam will be available until Monday, May 18th, until 11:50. Right. So when we hit 11:50, we can't access anything anymore. Right. So all assignments are available until that Saturday, May 16th. And then I went on and made the final exam available until that last moment of class, right? So that until Monday, May 18th at 11:50 a.m. Okay. Um,
So
but yeah, the final exam is up. The best thing is just to go ahead and get her done. All right.
I went on to make the
All
final
right.
exam.
So I'm available if you all have questions. I'm proud of you all. Just finish strong, push, do the best that you can. It'll be okay. Okay. Just do the best that you can. On that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Peace. All right. So I'm available if you all have questions. I'm proud of you all. Just finish strong, push, do the best that you can. It'll be okay. Okay. Just do the best that you can. On that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Peace. So I'm available if you all have questions. I'm proud of you all. Just finish strong, push, do the best that you can. It'll be okay. Just do the best that you can. On that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Thank you.